Hello, algebra students. Today we're going to be learning a new method of solving systems of equations, and this time we're going to be using the elimination method. So last time we used the substitution method where you found one value for a variable and you plugged it into the other equation or either equation and you found the other value. Now we're going to use what's called elimination, so we're going to be trying to eliminate or cancel variables in order to solve our systems. So in your notes packet, you have the general steps for using the elimination method, and we'll refer back to these. So make sure you have these on hand as you go through the problems. So in problem 1, we're going to, you can see, do it basically 2 different times. So what we're going to do is, if we look at our steps, the first step says write both equations in standard form. Basically, we have to have everything in the same spots. So that's already done. We've got our x's, our y's, and then our equals and our constants. Then it says multiply one or both equations so that one of the variables will be canceled out when combined. So what that means is we can look at our x's and our y's, and if we add or subtract the 2 equations, will we be able to get rid of one of the variables by doing that? If you look at your y's, they both have the same coefficient, 3, and they're opposite. That's the key, is we want opposite but the same. Same number, different sign. And so we have 3y, negative 3y. If we add these 2 equations together, those will cancel out. So go ahead and do it. We're going to say 4x minus 5x is negative x. 3y minus 3y is 0. Great news. And so then 5 minus 4 is 1. So what we've done is we've eliminated the y, and that's why it's called the elimination method. So now we just need to finish this one. Negative x is 1. Remember the trick, just switch all the signs. If negative x is positive 1, then positive x is negative 1. So now we know what x is. We can use the same method to find y, and I call this double elimination. Sometimes I'll allow you to just substitute in, but on this one, it's we're going to practice using the elimination method. So now we're ignoring the y's. We're not trying to eliminate y, we're trying to eliminate x. So you can see we have 4 and negative 5, so they're already opposite, so we're going to multiply by positive numbers for both. But we need them to match. So it's sort of like when you're dealing with fractions and you want a common denominator and you're looking for what that value is going to be. We're basically looking for a common denominator here, just not with fractions. So the least common multiple. So when we're looking at 4 and negative 5, they don't share any common factors. And so the smallest common, same, multiple is going to be 20. So to get 20 as our variable, right, that's our goal, is to have 20x in both of these, 20x and negative 20x. To get there, in the top equation, we're going to have to multiply by 5. Okay, so let's go ahead and multiply by 5, and you can see the little arrows. We're distributing that 5 to all 3. So we're multiplying 5 times 4x, 20x, 5 times 3y, 15y, and 5 times 5, 25. So then think about what you need to multiply the next one by to get negative 20x. We already have the negative, so what times 5 is 20? Hopefully you said 4. You're going to do the same thing. Don't forget to distribute. So multiply everything by 4. And you should get negative 20x minus 20y equals negative 16. Keep all of the signs the same. Now, same as before, you're going to add the 2 equations, these 2 new equations together. So 20x minus 20x is 0. So we've now eliminated the x's. And then 15y minus 12y is 3y, and 25 minus 16 is 9. Now, just like before, we need to solve our new equation, so we're going to divide both sides by 3, and we find out that y is 3. And of course, you can always, or should always, go back and check your values. You're going to plug both numbers in to both equations and verify, and you can use your calculator for that. Okay, so we're going to try again, keep practicing. So if we look at our next example, we've got 2x and negative 2x for our x variables. They already match but are opposite, so we can add the 2 equations together. So double check that you do get 0, so 2x minus 2x, 0, great. 3y plus 9y and 11 plus 1. Divide both sides by 12, and you find that y is 1. Then if we're looking at the y's, so I just rewrote the problem. Now I'm looking at 3y and 9y. This time to get matching values, we don't have to multiply the second equation because 3 goes into 9. 9 this time is the least common multiple. So you can see underneath I rewrote that second equation all over again. I didn't change anything. It's exactly the same. But so we need to multiply to get a 9 for the top equation, but not only that, we have both positives. If we add positive and positive, we don't get a 0. So we want to multiply by a negative this time. So you're thinking, what times 3 gives you 9? Or really, negative 9. So we're going to multiply this time times negative 3. Don't forget to distribute. So we're multiplying negative 3 times 2x, negative 3 times 3y, and negative 3 times 11. And one important thing when you're solving your systems with either method, but especially with elimination, is keeping your work organized and really showing everything, lining it up. It's going to make it a lot easier for you. Okay, so we have multiplied everything. Now, double check. We have negative 9, positive 9 for our y's, so they match but are opposite. So go ahead and add the two equations together. Of course, you're verifying that you do get a 0 here. And then we're going to divide both sides by negative 8. And we find that x is positive 4. Again, you can go back and check your solution in both equations, plugging in 4 for x and 1 for y. Okay, so hopefully you're feeling really good about this. So let's try again. On the next one, I'm going to be multiplying my second equation only. And so we can multiply to eliminate x, and then later we'll multiply to eliminate y. And so I just rewrote the first equation. I didn't change anything, right? 18x plus 6y equals 6. Rewrote it. Then I'm looking at so first I'm looking at my y's, and I'm looking to see, well, 6 and 2 actually share, 2 is a factor of 6. So that means that 6 is the least common multiple there. So we need to keep in mind that we have the same sign. We need an opposite sign, so we're going to multiply by a negative. And we're thinking, what do we need to multiply 2 by to get negative 6? And hopefully you said negative 3. So you've rewritten the first equation. Now distribute negative 3 through the bottom equation. Okay, double check your work. And now that we have a matching but opposite, positive 6y, negative 6y value there, now we can add our two equations together. Okay, from there you can divide both sides by 24. And we find that our x value is 2. So we're going to start over, and it's really helpful to rewrite your problem. And again, I'm just going to multiply the second equation. And the reason that I'm doing that for both of these is that 2, the coefficient for both of these, goes into the other two numbers. So 2 goes into 18 and 2 goes into 6. So I don't want to multiply the bigger numbers to make even bigger numbers. I want to keep those if possible. And so this time I'm trying to eliminate x. So I want a matching number. It's already opposite. So I need to multiply 2 by something to get 18. Hopefully you had 9 in your mind. So we're going to multiply everything here. Don't forget to distribute by 9. So you'll get negative 18x plus 18y is negative 126. And since we're multiplying by a positive because it's already negative, you're not changing any signs here. Where on the last one we had to change every sign because we multiplied by a negative. Okay, go ahead and add your two equations together. And then divide by 24 on both sides. And you find that y is negative 5. So hopefully you're feeling pretty good about this. We're going to do one more example and then move on to our word problems. Okay, so if we look at example 4, this time we don't have factors in here. So 3 and 2 don't share a common factor. 2 and 5 don't either. So it doesn't matter which one you choose first. You can pick either variable to try to eliminate. And I believe I eliminated x on these just because the numbers are smaller, but it really does not matter. So if we're going to try to eliminate our x's, we need to think about what do we need to multiply 2 by and what do we need to multiply 3 by. right? It's that same common denominator thing. Okay, so the least common multiple here is going to be 6. You're going to try to multiply the top equation by something that's going to get you 6. So how about 3? You're going to multiply the bottom equation by something that's going to get you 6, so that's going to be 2. I happen to choose multiplying the top equation by a negative. It doesn't matter which one, as long as you multiply one of them by a negative and one by a positive, since we have the same sign here. All that matters is that we get opposite matching numbers. So opposite signs, same number. So when we do that, go ahead and multiply through the top equation, distributing your negative 3, and distribute 2 across the bottom equation. Once you have that, you have matching 6 and 6, but positive for the second one, negative for the top one. And so now we can add our two equations together. Then from here, divide both sides by negative 19, and you find that y is 1. Now, if you remember on the first problem, we eliminated our y's and solved. Then we multiplied to eliminate our x's and solved. And that was because we were getting used to doing these types of problems. And that's called the double elimination method, where you have to use elimination for both. And sometimes I'll specify that you have to use elimination for both. However, there's another way that we can do it. Once we know what y is, we can pick either equation. We can plug y in, or 1 in for y, in that equation and solve. So you're substituting for the second part, which is what we learned the other day. So I just happen to pick the top equation and just rewrote it. Right? You can see it's exactly the same. And now what I'm going to do is I'm going to substitute 1 in place of y. And then from there, continue simplifying your one variable equation, and you can solve that one to come up with x. You can, of course, go back and do the elimination method and eliminate your y's, just like we did example 1. And you should get the same answer either way. And as always, you can go back and check your work by plugging both numbers into both equations and make sure you get the right answer. Okay, so now that we know how to use the elimination method, let's try it out on a word problem. So we have the sum of two numbers is 115, where the difference of these same two numbers is 21, so you'll fill in the blanks in your notes. And one thing that I like to do a lot of times on word problems is I like to start with the answer. And so the question here is saying, what are the two numbers? So we can fill out an answer blank and just leave blanks because we obviously don't know what they are, but I'm just using the wording there and reversing it to write it as a sentence. What are the two numbers? The two numbers are blank and blank. And the reason I like to do that first sometimes is it, for starters, gives me a point. If I even get the answer wrong or can't do anything else with the problem, I get 1 point just for writing the sentence. So that's one incentive. The next is now, this is helping me figure out what my variables need to represent. My variables need to represent the two numbers. So we can say that x is a number, and then y is going to be the other one. Then I'm going to go back up here, and I'm looking at the sum of two numbers, being 115. So go ahead and write an equation that represents that using x and y as your variables. The sum of these two numbers is 115. Remember, sum is addition. Okay, so what you're going to write is x plus y for sum, and then is, remember, is equals, so equals 115. Okay, now we need to write an equation for the difference of the two numbers is 21. Okay, so difference, remember, is subtraction. We don't know the order we're supposed to do this in because we don't know which one is going to be bigger or smaller, so it really doesn't matter. So when it says write the difference, just pick whatever order you want. So we can say x minus y is 21. Okay, so now we've got our system of equations from these two parts of the problem. And what do you know? Our y's are already matching but opposite, positive y, negative y. So if we add our two equations together, we've eliminated y. So then all we need to do is divide both sides by 2, and we figure out what x is. All right, so even though on the last one we used elimination and then we used substitution, just for fun, let's try to use elimination again. So if we're trying to eliminate x, we have the same coefficient 1, we need them to be opposites. So let's keep the top equation exactly the same. Just rewrite it. X plus y is 115. But the bottom equation, let's just reverse the signs. Change every single sign, multiply by -1 all over the place. So negative x, positive y, negative 21. Now we can add the two equations together, divide by 2 on both sides, and we come up with our other number. And so then from here, you can go back and double check, right? Just on your calculator, add the two numbers, make sure you get 115, subtract big minus small, make sure you get 21. And then you can fill in your blanks in your sentence frame that you already wrote. The two numbers are 47 and 68.